What America bought with taxpayer money was not a prototype chip. It was the first road. The road that lets cutting-edge defense semiconductors get into Intel's fabs. That is how I read this news. Intel has announced the completion of RAMP-C, its prototyping program for defense applications. On the surface, it looks like a quiet, low-key announcement, but I think it connects directly to Japan's Rapidus.
Hello everyone, I'm Ty, with 31 years in the semiconductor industry. Today I'm taking up RAMP-C, the US prototyping program that Intel has just announced it completed. In this video, you'll learn what was actually achieved in RAMP-C, why a government would use tax money to support the very first customer, and how all of that ties back to Japan's Rapidus. Let's get started. Let's start with a simplified analogy. Imagine that a new, tall mountain has just been opened up, with a spectacular view from the summit. The problem is, this mountain does not have a single climbing trail on it yet. No maps, no ropes, no steps, no mountain huts. If you want to reach the top, you have to carve your own path through untouched terrain, entirely on your own. And there are people who absolutely need to climb this mountain. A survey team that has to confirm the view from the summit for important national work. But the team is tiny, just a handful of people. Hanging ladders on the cliffs, bridging the gaps, putting up trail markers, all of it for a few surveyors. And every bit of that cost falls on whoever climbs first. The burden on that first team is enormous. Scouting the route, reinforcing the dangerous sections, drawing up guide maps, setting up a way to call for help in an emergency. Every one of those has to be built from scratch. And because so few people will ever climb, there is no way to recover the money that was spent. Viewed purely as a business proposition, it is a job nobody wants. So what happens is this. The survey team either keeps making do with the lower mountain it already knows, or gives up on climbing altogether. They genuinely need the view from the new mountain, and yet the first step is simply too expensive for anyone to take. That is when the government stepped in. It put public money behind that first survey team, covering everything from opening the route to building the mountain huts. Once the trail exists, the second and third climbers can walk up an established path with far less effort. What the government bought was not just one team's climb to the summit, it was the road itself, a road that everyone who comes later can use. Now, let's look at the actual news. On July 28, 2026, Intel Foundry, Intel's contract manufacturing arm, announced the completion of RAMP-C, the US Advanced Semiconductor Prototyping Program. RAMP-C began back in 2021 as a joint effort with US defense authorities. Its purpose was to build a technology foundation for advanced chips that can be designed and manufactured inside the United States, and to help commercial companies and defense industry customers move from prototyping toward readiness for volume production. The program ran in 3 stages. First, design tools and IP were prepared for Intel's next-generation process, Intel 18A, giving customers the foundation they needed to design test chips. Next, commercial and defense industry customers were actually brought into the development environment, and that design environment was expanded further. In the final stage, defense industry customers took a product prototype all the way to tape-out, that is, handing the design data over to manufacturing, and then evaluated the prototype chips that came back. The process used here, Intel 18A, is a next-generation node that adopts RibbonFET, a new transistor structure, together with PowerVia, which delivers power from the backside of the wafer. What matters is that customers got as far as actually designing, manufacturing, and evaluating real prototype chips. That said, volume production of defense products is still ahead of us, and this announcement is not evidence that volume production has succeeded. In 2023, the defense majors Boeing and Northrop Grumman joined RAMP-C, and Microsoft, IBM, and NVIDIA have also been named among its customers. In 2025, 2 more highly specialized companies took part in the 3rd stage, and the results are being handed over to Secure Enclave, the program for safely producing advanced chips for the US government at volume, inside the country. Here is the heart of the matter. Most media outlets frame this as a technology story,
proof that Intel 18A development is on track. But what caught my attention is somewhere else entirely. The US government used tax money to build the first road that lets military and defense semiconductors get into Intel 18A. That, I believe, is where the real meaning of this news lies. So why does building a road require tax money? Military and defense chips are essential to a nation, but from a manufacturer's point of view, they are not an easy business at all. The volumes are small compared with smartphones or AI servers, and yet they demand a great deal of extra handling. Export controls, keeping design data confidential, tracing manufacturing history, and much more. On top of that, at the leading edge, the cost of masks, design, and prototyping is enormous. You sell very little, and the first wall you have to climb is extremely high.
This is where Ramp C is clever. It did not build a dedicated fab that only runs military chips. Instead, the 18A process, the design environment, and the advanced packaging that Intel is building for its commercial customers were made available to defense companies as well. In other words, it is a mechanism that lets a small amount of defense demand ride along on a huge commercial manufacturing base. In an area where, left to the private sector alone, companies would either settle for older processes or abandon development entirely, tax money created an entrance. And this road building is not a one-off with Ramp C. U.S. defense authorities have also been running a program called SHIP, which brings advanced packaging back onto domestic soil. Ramp C builds the road for design and prototyping. SHIP builds the back-end capability to combine chips together, and Secure Enclave connects all of that to secure volume production. Bringing only the front end back home is incomplete if the back end stays overseas. Here is my take. Once a road for military applications is opened on Intel 18A, the companies that follow have a dramatically easier time. Verified IP, established design procedures, proven ways of handing over data, and a track record of manufacturing and evaluation are all available to them from day one. Set against the burden of building the same setup from zero at another fab, a natural pattern emerges. If you need leading-edge logic, you look at Intel first. To me, this looks like national policy designed to make Intel the standard entrance for leading-edge military logic. Of course, not every military chip is going to end up at Intel. Analog and power semiconductors, for example, each have fabs that suit them better. And whether 18A pays off as a business depends on volume production and on winning commercial customers from here on. Even so, I don't think the value of having built that first road is in any doubt. And this story connects directly to Japan's Rapidus. The wall Rapidus has to get over is less a wall around military applications than the wall standing between Japanese companies' design capability and funding on one side and a 2-nanometer class foundry on the other. At the leading edge, mask and prototyping costs are high, and it is far from easy for universities, startups, or domestic fabless companies to step up as that first customer. Shouldn't support go not only to the side building the fab, but also to the customers who design and tape out first? Subsidies for a fab create supply capacity, but support for the customers who use that fab first creates a road that everyone behind them can walk. In the process of that first company completing a design, running a prototype, and evaluating real chips, design rule problems get found, IP gets verified, and the procedures for supporting customers get established. That is not a subsidy handed to one company. It is the building of public infrastructure. Japan, I think, needs to bundle together the demand that actually exists, AI, automotive, industrial equipment, and use it to build that road. Let me sum up. Intel has completed Ramp C, reaching prototyping and evaluation with defense customers on Intel 18A. The results are being handed over to the Secure Enclave program, worth up to $3 billion. The core of this is not technology. It is a policy template. The road that the first customer walks has a public character, and there is real meaning in spending tax money to build that road. And that, I believe, is exactly what Japan should be learning from with Rapidus. That's all for today. I'll keep bringing you semiconductor news and analysis, so if you found this useful, please like, subscribe, and I'll see you in the next video. This has been Ty on Semiconductor News Decoded.